everyone, so in this video we're going to show you how to invert a matrix using elementary operations, right? So compute the inverse of a matrix through elementary operations. Now I'm assuming that you're familiar with what a matrix inverse is, right, and what some of its basic properties are, and if you're not, please feel free to go and check out our video on what a matrix inverse is, right? And that will give you a basic idea of what an inverse is. Also, if you're not familiar with what the matrix elementary operations are, please go check out our video on elementary operations on matrices, because when I do this, you're going to use the elementary operations and I assume you know what the operations are, so I'm just going to apply them straight away. So we're going to start with this 3 by 3 matrix, right? And we're going to work through it and try and compute its inverse using elementary operations, right? So this symbol A inverse, if you're not familiar with it, this A minus 1 as a superscript is, indicates the inverse of A. Now we know from the properties of a matrix that if you multiply the matrix A with its inverse, so A inverse A is the identity matrix, right? And if you do A inverse, that's also the identity matrix, right? So to compute the inverse, what you do is you start by saying A is equal to IA, right? Because a matrix multiplied by the identity matrix is the matrix itself. That's a property of square of matrices, and we're doing this for square matrices, right? If you're familiar with the inverse, you know that the inverse cannot be computed for rectangular matrices. So what you do here, now you've written A is equal to IA. What we're going to do is we're going to expand this, right? So A, we have written the matrix. This is our A. We've just shown it to you in the previous slide that this is the matrix we want to compute the inverse of. We've expanded I, the identity matrix, and it's the 3 by 3 identity matrix because the matrix we want to invert is a 3 by 3 matrix. And we've left A as it is, right? So we've expanded this A or written the matrix there. We've left this A as A. Now what we're going to do is we're going to apply a collection of elementary operations, right? And you can apply them either to the rows or column wise, right? And stick to whichever one you use. So if you're doing row wise operations, just use row wise operations throughout and complete the process, or if you're doing column wise operations, just do the column wise operations throughout. So the first case, I'm going to do row operations on the matrix, right? So what we do is we apply the row operations to this equation, which means we'll apply it to both the left and to the right. So we'll apply it to this matrix, which is A, and to the identity matrix. And what we'll end up with at the end of that process is we'll end up with this left hand side becoming the identity matrix. So as you apply those row and column operations, what you're going to aim at, or your aim, right? Because how do you know which row and column operations to do? Well, it's simple. We're taking this matrix, right, A, and we're going to apply the operations that ensure that we end up with this identity matrix on the left. And we know that we've left A as it is. We're applying all the other operations to this particular matrix, the identity. So we know that if something is multiplied with A and the result is the identity matrix, and that something has to be A inverse. So this identity matrix on the right becomes A inverse, right? So you started with A is equal to IA, and when you apply the operations, you end up with I on the left. So this A becomes I, and the I, or the identity, becomes A inverse, right? Okay. Now, I mean, if you're still a little confused, don't worry. As we go through the entire process, you will really understand this, right? Okay. So let's start this process. Now, it's important that when you apply the elementary operations, you apply the exact same operations to both these matrices, right? So if you do, say, a row scale, you take the second row and scale it by 2, then make sure you do the exact same operation here. You can't do a different operation on the right side, right? So that's something you need to be very careful about, right? And what you end up with is you start with this and you end up with this. So identity on the left and the inverse terms. And what I mean here is these are the terms of A inverse, right? It's not A11 inverse, it's A inverse 1 1, meaning it's the elements of the A inverse matrix. Okay, so let's start with the first step. So if you remember what I just told you a second ago, the goal is to convert this into the identity matrix, right? So what do you do? Well, you need to zero out these terms. You need to zero out this, you need to zero out this and this, you need to zero out this and this, and you need to convert this into 1, right? Now, as we do these operations, some of these terms will change, and so some of them will become 0 automatically, some we have to convert to 0. So we're going to apply row operations. So we're going to apply an operation to each row wise, meaning you will apply, say, row 1 plus row 2, or row 1 times row 2, or row 1 times a scalar, or so on. And so the order at which I'm going to make the term 0 is column wise, right? Just remember that if you're applying row operations, then if possible, go column wise, go like this, make this 0, then make this 0, then make this 0. And if you're doing column wise operations, then go row wise. So I'm applying row operations. I'm going to make this term 0. So how do I make this term 0? I'm applying matrix operations. I say, okay, this term is R2. R2 is R2 minus R1. And what happens when you do that? You get 1, this row now, the second row now becomes 1 minus 1 is 0, because R2 is R2 minus R1. So 1 minus 1 is 0. 1 minus 2 is minus 1, and 2 minus 1 is 1. And you have to apply the exact same operation to the right hand side. So you get 0 minus 1 is minus 1, 1 minus 0 is 1, and 0 minus 0 is 0. So as you can see, this term has become 0, and here this has changed. This term has become non-zero. Okay. What's the next thing you do? Okay. So you want to make this 0 now, right? Because you want the identity matrix here. What you also see is by doing this operation, this term has changed, this term has changed. So the terms have changed right here. So that's why it's important to go step by step. Okay. So now we want to make this 0. So which operation do we use? You can't subtract with this because this is 0. So you take the first row and you do the same operation. You do R3 is R3 minus R1. Right. So now this row now becomes this minus this. So 0. 2 minus 2 is 0. 2 minus 1, 1. And on the right hand side, 0 minus 1 is minus 1, 0 minus 0 is 0, and 1 minus 0 is 1. So this term has changed, but now you've got the first column of the identity matrix, right? You've got that sorted. Okay. So what's the next step? Can you guess? Okay, so hopefully you've guessed right. You want to make this term 0, right? This term 0. So how do you do that? So what's important now, and I'm saying it at this point, right, because it's a mistake that happens quite often. You want to make this 0, but you do not want to disturb this. You want to keep these two as 0, and you want to leave this as 1. So you don't want to do anything that will disturb this, because otherwise what's the point, right? If you do something and this becomes 1 or 2 or something else again, then you have to again go back and zero it out. So you have to make sure that whatever the previous changes you have done to this matrix on the left hand side, right, they are retained, right? So 1 0 0 needs to be retained. So what do? Well, you can't do anything with the third row, because you can't subtract or add with 0. It doesn't change anything. You can do it with the second row. So you apply R1 now, and you're applying it to R1 because this is the term you want to remove. R1 is R1 plus 2 times R2. So the advantage is this is 0, which means the 1 does not get changed. And then the second term, right, so that's unchanged. This now becomes 0 because it's 2 plus 2 times minus 1, which is 2 minus 2 is 0. This becomes 1 plus 2 times 1, which is 3. If you look at the right hand side, this becomes 1 plus 2 times minus 1, which is 1 minus 2 is minus 1, 0 plus 2 times 1, which is 2. And we've ended up with this 0. So you can see slowly we are getting towards an identity matrix. And what I'd recommend is, if at any time you are confused, just pause the video, just go ahead and try these steps out. And you can see them on the screen, so you can see if you're getting the same steps, right? If you make a mistake, just pause it, go back and start again. Okay, so now we'd have this term. Now, normally what you could do, and this is minus 1, so you don't need to make it 0, because for an identity matrix, it's 1, 1 and 1 on the diagonal. So all you have to do is multiply this row and this row by minus 1. And you could do it right here. Now I have done it later because I'd like to first get all my zeros in the matrix and then scale any row or column. But you could just here multiply this by -1 and multiply this row, the second row, by -1, and the whole system changes. Okay, so like I said, I'm going to first focus on the zeros. Now this needs to be 0, it's 0, right? Luckily, it need not be the case, and so if it's not the case, you have to go and make this 0. But it's 0, so let's move on. Now if this was not 0, you would use the second row, right? Because if you use the first row, this 1 affects this, and so this term would get this 0 would get defeated. So what you would need to do is use the second row, because in the second row this is 0 and this is 0, the third row. So you would only have, you do R2, R3 is R3 minus R2 or R3 plus R2 or something like that, and you would make this 0. But in this case, it's already done for us. So now we want to sort this out, 3. So which row or column do we use, right? Now we could use the second one, R2, right? But the problem is if you do R1 is R1 plus R2 or minus R2 or minus 3 R2, this would become 0. But now this would become minus 3. So you can't use the second row. So you have to use the third row. And that's why you do this column wise, right? So now you've done with this column, when you get here, the first column is sorted, the second column is sorted. And so you have this, this third row here with the 2 zeros in the first 2 columns. You'll understand this as you practice this. So we do R1 is R1 minus 3 R3. And so what you get is this remains the same because you're multiplying by your, minus 3 times 0. So that doesn't get changed. This doesn't get changed. You get 3 minus 3 times 1, which is 0. And on this side, it's interesting because, the first term here is not 0. So you get minus 1 minus 3 times minus 1, which is minus 1 plus 3, which is 2. You get 2 minus 0, which is 2. And here you get 0 minus 3 times 1, right, which is minus 3. So you end up with this matrix. Now you need to zero out this term. Now it's very simple, as you already know from the previous step. You just do it with R3. So you do R2 is R2 minus R3, right? So R2 becomes 0 minus 0 is 0, minus 1 minus 0 is 0, minus 1, and 1 minus 1 is 0. And on this side, minus 1 minus minus 1, so that becomes 0. 1 minus 0 is 1, and 0 minus 1 is minus 1. And you can see now that all the off-diagonal elements have become 0. Now there's only one thing that needs to be changed. This particular term needs to be made 1. So what do? You do R2 is R2 into minus 1. Because if you remember the 3 elementary operations, it's either scaling a matrix by a scalar, or it's flipping a row or a column. So it's either scaling a row by a scalar or scaling a column by a scalar. Second one is flipping rows and columns. The third is taking a matrix and to that adding a scale times another row. So till now we've only used the third elementary operation. We're now using a different one. We're saying R2 is R2 into minus 1, which means this becomes 1 1 1. You've multiplied here by minus 1, so this row, the sign of this row changes, and you've ended up with this matrix. So you've ended up with identity on the left, and so this matrix then has to be the inverse of the matrix, right? Now what I'd recommend is, if you're a bit confused, just go back to where I started and just do this whole thing again. And if possible, just solve it, using a pen and paper while you watch the video, or just pause it and solve it. Do each step, pause it, watch each step, pause and do it yourself, and it'll become clear, right? And let's try another case, right? So you've seen A and A inverse, and if you multiply A with A inverse, you should get the identity. So it's a good way to check that you've got the inverse right. Once you compute the inverse, just multiply A with A inverse, and if you don't get I, then you know that you've made a mistake somewhere. Alright, great. So let's do this again, right? So, and now I'm going to use column operations. But it's the same approach, so you should get the approach very easily. So this is my matrix, right? And I'm multiplying, that's my A. And so I'm saying this is equal to A this. And in the previous case, we did IA. When you do column operations, you generally write it as AI, right? That's just the way it's written. So the first thing you see here is actually one thing you could do is take the first row, take the second row and say R2 is R2 minus R1, right? This becomes minus 1, but this term becomes 0, right? But another interesting operation, and we haven't used this in the previous case, but you do have the column switch elementary operation. So we're going to apply that. So we're going to say switch C1 and C2, and you have to do this on the other side as well. So 1, 0 becomes the first column, 1, 1 becomes the second column, and here 0, 1 becomes the first column. So this is now the first column, 1, 0 becomes the second column, and you've already got your 0 here. There's no addition, there's no subtraction, nothing. What's the other term you need to zero out? This one, right? So it's 1, 1 and 0, 0. How would you do that? Simple, right? You do R1 is R1 minus R2. Okay, so we're doing column operations. So same thing, C1 is C2 is C2, right? And you want to zero this out, C2 minus C1, right? Simple. So what do you get? You get 1 minus 1 is 0, 1 minus 0 is 1. And here you get 1 minus 0 is 1, 0 and minus 1 is minus 1. So you've ended up with identity on the left, and you've ended up with the inverse on the right, because we know A inverse is 1. So you've got A inverse, take the product and you will get the identity matrix, which means this is correct. So hopefully that's very clear. We've done two cases. We've used first row operations and then we've used column operations for the second case. Now I understand this is a bit complicated, but this is one of the toughest topics at this level for matrices. So feel free to just go back and try this again on paper, and then go ahead and take the quick test on TeachYaar.com, because we've put quite a few other cases, right, where we make you compute the inverse, and so when you do those, and each of these also has a learning section, right, where after you compute the test, you're done with the test, you click it and the learning section shows you the steps you should have done. So you get a little more practice and it'll be very useful for this particular topic. So to take the test, go to TeachYaar.com, and you can either scan the QR code on your mobile device to do that, or this link that you see here is the test link, and we have dropped this link in the comment section and the description section. So just go ahead and click that, and please go take the test, and it's free to take, right? And please subscribe to the TeachYaar YouTube channel.